Hey guys, Wes here. So, I don't know about you guys, but I think the first place I ever used the internet was at the library. So, I just finished designing a library management system in ASP.NET Core MVC, and I thought it would be kind of fun to make a series of videos documenting that project so you guys could follow along and we could do some full stack development. We're going to do everything from setting up and designing the database to implementing the MVC pattern, and then finally playing around with some front-end stuff like data tables and maybe some material design in Bootstrap. So yeah, the project was kind of fun, and I thought it might be something that you guys would be interested in checking out. So yeah, let's take a look. Okay, so let's take a look at the software we'll be building over the course of the next several videos. So we have here an integrated library system for a fictional library called Lakeview. So an integrated library system, also sometimes called a library management system, is the software that a library uses to lend its assets and sort of manage its assets as they're lent out to various patrons who might sign up for a library card within that system. So the library is going to control, its books, magazines, things like that. So it's going to need to manage all of its inventory and sort of control, how it lends out to its various patrons, and to keep track of what patrons have what assets and what patrons have certain items on hold, for instance. It's also going to want to track the different branches that belong to that library. So if you live, for example, in a larger city or region, then your library system might consist of multiple branches. Let's take a look first of all at our library catalog. So you'll see here that we just have a list of assets very simply in a table here. And so we're going to have like the title of whatever the asset is. In this case, we'll have a lot of books, the author or director, and then a Dewey call number. So if the library is using a Dewey Decimal System, this is just a way that they index their books. So yeah, we can see that the books all have covers. And if they don't, we have a no cover available icon here. So if we click on one of the books, we get taken to a detail page here. So we have a lot more metadata on this book that we can see. So we've got an ISBN, for instance, a call number. Again, this is the Dewey call number, the cost of this asset, what it is, so if it's a book or a video or anything, its last location. So the assets will be associated with a particular branch. Some checkout history, so in other words, what patrons have checked out this item in the past and over what period of time. And then also a list of current holds. So we'll look at what that means here in a second. So let's say I wanted to check this book out, so I just click here. And then we'd supply a library card ID to which we wanted to check out the book. And now we can see that the book is no longer available, but it has been checked out by this patron. And we can see now that we have a new checkout history started in the table here as well. So the book hasn't been returned yet, but it was checked out this time on this date. So now let's say that I'd like to check the book out, but I'm another patron, and of course it's not available for checkout yet, but I can place a hold. So we'll click place hold here, and let's say we'll put the new customer's library card ID here, and we'll place a hold. And so now we'll see that this patron has a hold on the item, and again, other customers can continue placing holds. And so we'll basically have a queue here of holds, so that when our customer Tomas here checks the item back in, it gets checked out automatically to the first person who had a hold on it. A new checkout history record is created, and the queue obviously drops one of the patrons. So again, if this is checked in by Mary Lee, it is now automatically checked out, and if he checks it in, the book is back to being available for checkout. We can also very simply mark the item as lost, at which point it can't be checked out. We can mark it found again. So that's our kind of simple check-in, check-out system. So if we go back home and we click patrons now, we can see how we can manage different patrons that are in our system. So we can see their overdue fees, what library card they're associated with, what library branch they're associated with. And if we click on one of the customers here, we can see their name, address, and some information that they might supply when they sign up for a library card, as well as the current items they have checked out and any assets that they have placed a hold on. We can also see if the customer has any fees on their account. It'll show up in red on their profile page here, so we can see that this customer has fees due. And then so we can base some logic on this and say, like, if the customer has a certain amount of fees on their account, they might not be able to check out a book or a video. Just a small other feature we have here, some other information we have on our patron object. And finally, if we take a look over at our branches page, we have another list view here where we have some data about the branch, how many patrons are associated with it, the number of assets that are associated with it, whether or not it is open. And if we click on it, we can see a picture, its schedule, so the dates between which the branch is open, the total value of the assets owned by the branch, and some more data, so like the description and some sort of profile data on this particular branch. And so each of the branches will have its own sort of profile page and the specific data associated with it. So yeah, this is our simple integrated library system or library management system, and it was kind of fun to build. It's a pretty straightforward application. It's not very large, but it would be a fairly decent starting point for an actual system that managed sort of any type of inventory or any type of check-in, check-out system where you'd have patrons, various locations, and various assets to control. So I think it's kind of a good general purpose project, particularly if you are interested in learning about the MVC pattern or just diving into some .NET. Okay, so I have Visual Studio open here, and so we'll go ahead and create a new project. So we'll just file, new project, and we're going to create an ASP.NET Core web application, and I'm just going to call it library, and I'll place this in a projects directory that I have here, and we'll make sure that it creates a new Git repo and creates a directory for the solution. So we'll select OK. And it's going to ask us if we'd like to use a template, and we're going to use the web application template, which is going to allow us to create an ASP.NET Core application with MVC. Okay, so you can see that by default here with this template we have a project structure in place already. And if you've developed an ASP.NET before, this may look a little bit different to you if you're coming to .NET Core for the first time. So something that you'll notice here is that we have a www root directory, and that's going to contain all of our static files, so CSS, images, JavaScript, third-party libraries, and you can see that the template has brought in jQuery and Bootstrap. And yeah, so we can actually use this directory to serve up our static files when it comes time to load some of those a little bit later. And then we have directories for our controllers and views. And so the template has provided us with a home controller and some views for the home controller here, as well as some shared views, so a layout and an error page here. So the layout.cshtml, this is actually going to be shared by all the other views in our system. And so you'll see that we are implementing Razor syntax here. So anytime you see a spiral and then some keyword here, we're going to be using the Razor templating engine. And so that we can dynamically render HTML on a page in these CSHTML files. So you'll notice that towards the middle of the page here, after we define the head and the body tags and we have a nav bar, inside of this div with the class container body content, we have this render body method that's being called after the spiral here. And so this is actually where all of our views will be rendered by default in our application. So very quickly we'll take a look at the application that the template has provided us with, and we can just fire up the browser clicking the IIS Express button up here with a play button. You can also hit F5 as long as the library is set to your startup project. Okay, so the browser is going to pop up here, and I'll just maximize it. It may take a little bit longer to fire up the application if this is the first time that it's being built. And it's worth noting that unlike in some scripting languages, so if you're familiar with developing web applications in Django using Python, or in a particular JavaScript framework. If you have a small node server running, we're actually going to need to stop and start our server anytime we work on compiled code, so things like code that's in our controllers and models. Okay, so we have the application up here, and you can see that it has created a simple home page for us that has a sort of carousel slider here. And then we have a nav bar up top here with home, about, and contact links. So if we click on these, you'll notice that pages are getting rendered for us. And if you take a look at the URL in the browser, you can see that all of the links that we click on here are relative to this home path. So home is the controller that our application is using in this particular case, and then the action will be the second part of our path here. So home/about is going to look in the home controller for an about action, and home/contact is going to be looking in the home controller for a contact action. And then our index page looks like it's rendering probably the index action on the home controller by default when we have nothing in our route here. So let's take a look at where that's configured. So I'm just going to close the browser and hit stop, and we'll come down here to, we'll close our view and controller folders, and we'll come down here to the startup.cs file, which contains our startup class. And this class contains a constructor and two methods, the configure services method and configure method. If we look inside the configure method, you can see where we are actually telling the application how to do its routing. So we have a default route here where the controller is going to be set to home, and then we'll have /index/ an optional ID that might get passed here. So you can imagine that we might have, for example, like a detail view, where if we had, say, like an images controller, and then so like images, and then a detail action where we were going to pass the ID of a particular image, then we could go to like a detail page for that image. Let's talk a little bit about this startup class as a whole. So again, if you've developed an ASP.NET application in the past, you may be familiar with seeing like an app.config file and a global ASAX file here in your project structure. Everything now is going to be handled inside of our startup.cs class, and you'll notice that in the constructor for this class, we are actually going to be building all the configuration for this application using this configuration builder class. And so all the configuration is going to be stored in a series of JSON files that might contain any configurations that we set for our application. And so we'll have pairs of keys and values in JSON files that will represent the various configuration values that we might need to use. And if we have new JSON files that we'd like to add to our application, we can actually just chain another add JSON file method here onto our configuration builder to apply those configurations. So that's pretty straightforward. Note also that we can add environment variables to our configuration builder, which is kind of nice because we could store things like database passwords, connection strings, or any other type of configuration that might be particular to an environment that our application is deployed to. Those can be set here, and they can actually be set last so that they'll overwrite anything that is set in the JSON files that live with the application itself. So this is how we'll build out the configuration for our application, and we'll go to the app settings.json file in a little bit when we specify the connection string to the database that we'll be using. Okay, so if we come down now to the configure services method, you can see that we have a comment here that says this method gets called by the runtime. Use this method to add services to the container. So .NET Core is leveraging the concept of dependency injection here, and so you'll see that as we create various services that are going to handle working with our data sources, say working with a database or maybe some response from a remote API, what have you, we'll register all of those services here in our configure services method. We'll go through an example of that shortly as we create a services layer for this application. And if you're wondering about sort of what I mean when I say services, they are essentially just objects that have a particular functionality for other parts of our application. And then we can actually inject those services. And so say like our controllers might require us If we have a controller for, say, our books, we might have a book controller that we'll create later. We'll have a book service that we can actually inject into our book controller so that it can retrieve data about the books we have coming from any particular data source that we might want to implement. In our case, we'll be using a database, but we'll construct it in such a way that the controller simply asks for what it needs via this service that we'll create. And that'll be nice because we won't be doing things like throwing a DB context directly inside of our controller or any part of the application that wants access to the database. We'll be instead injecting this service. Okay, and then if we look down again at the configure method, this is where we saw our use MVC called here on the app. All of this is middleware. So middleware is going to be the components which handle HTTP requests and which produce an HTTP response. So we'll have things like use static files called here, and we'll control what types of error pages are shown, for instance, depending on what type of environment we're running in. And so the configure method in general is setting up what would be called our request pipeline. Okay, we won't actually have to do much, or if anything, in our configure method for this application, but we will be revisiting the configure services method as we go through and add services to our project. Okay, so now we'll take a look at our program.cs file, which contains our program class. This is the actual entry point for our application, so you see that this is where our main method gets called, and this is where we're actually going to run our web host. And so, similar to a configuration builder, we have a web host builder here, where we will be setting up the web host that we want to run when our application starts. So Kestrel is a lightweight server, and you can see we have IIS used as well, which is a little bit more of a full-fledged server. And you can see that we're going to use the startup class where we set up the configuration and middleware for our application. And eventually we call build, and then once the web host is built, we call run on it. And so that's basically how our application gets bootstrapped. All right, and the last thing we'll look at before we get into writing a little bit of code is if we look at the app settings.json file, you'll note that this is part of the configuration files that we are building for our application. The only key that we have in here right now is one for logging here, but very shortly we'll add a connection string to the database that we'll want to use. I think now would be a good time to start thinking about our data, and so what we'll do is go ahead and right click on our solution, and we're going to add a new project, and we're just going to call it library data. And we need it to actually be a class library. So this is just going to hold a bunch of C# files for us. So we'll say OK. And this data class library is where we're going to implement Entity Framework Core. So I'm going to right click here and select Manage NuGet Packages. We're going to click Browse here so that we can browse online. And we're going to add Microsoft.Entity Framework Core. And so you want to make sure that you select the option that says Entity Framework Core and not a previous version of Entity Framework. So we'll go ahead and install this. This is going to be our ORM. So it's going to be used to essentially map the data from our entity models, which are just plain C# objects, to our data source, which in our case is going to be a SQL database using Microsoft SQL Server. And so to use Microsoft SQL Server with Entity Framework Core, we need to also install Microsoft.Entity Framework SQL Server. So we'll go ahead and install that. It's worth noting that with Entity Framework Core, Microsoft now supports the use of other types of databases besides SQL Server, and apparently even non-relational databases. So I assume that means sort of document-based databases like NoSQL databases, maybe like MongoDB or something, are supported, although I don't have any experience implementing those in a .NET project yet. But if anyone else does, I would be interested in seeing it implemented. Okay, and the last thing that we'll add here is Microsoft Entity Framework Tools. And this is going to allow us to use the Package Manager console to do database migrations. So Entity Framework Core is exclusively a code-first ORM, meaning that we're actually going to write all of our entity classes in code first. Then Entity Framework is going to look at the models that we created, compare them to some database that we'll tell it to connect to, and make any changes to that SQL database. So actually like creating tables from the class names and creating columns from the property names, and basically generating a complete SQL database just by looking at the structure and content of our C# classes. Okay, awesome. So now we have a library data class library that's set up with Entity Framework. And the first thing that we need to do to work with Entity Framework is to create a class that's going to inherit from Entity Framework's DB context. And so DB context is essentially the link that exists between your entity classes and the database. So as I said, we'll be writing all of our database models, if you will, our entity models, in C# classes, and Entity Framework needs a way to make that mapping. And so we need to create that particular DB context class that will be responsible for interacting with that data as a C# object. So let's just go ahead and do it, and we'll take a look at what it looks like. So by default, for some reason, when we create a new class library, we get this class1.cs file in here. So we're just going to rename this. So right click and rename, and I'm going to call this library context. And we'll say yes to rename references in the code. So it's going to say public class library context here. And so as I said, we need to actually inherit from the DB context abstract base class that is provided by Entity Framework. So if you hit Control period over DB context, you'll see that you can implement this using that we need to include at the top of our file here. Okay, and now we're just going to create a constructor for this class. So we'll say public library context, and we're going to pass it DB context options, which we can just call options. And then we'll take these options and pass them to the base class constructor. So we can just do that by saying base options. And it's really as simple as that in terms of just setting this class up, but the important thing here is that we're going to have a series of what are called DB sets. And so it'll look something like this. So we'll say DB set, and then we're going to specify the entity object here. So for instance, if we have a patron object, and we'll use our property accessors here. Okay, so we don't have a patron object yet, but I just wanted to show you that this is how the library context will be structured. And so our table is going to map to our patron object, and then the properties on that patron object will map to the columns in that patron's table. So let's go ahead and actually create a patron object. What I'll do actually is right click on library data, and we'll add a folder for all of our domain models here. So we'll call it models. And in a moment, I'll go over all of the different objects I think we'll need to consider when creating an integrated library system. But for sure, we'll need something to represent the patrons. And so we'll just use that as our first example here. So what I'm going to do is add a class, and it's just going to be called patron. And we'll make it public so that it can be accessed by our library context. And so the way that this is going to work is we're just going to make this a plain old C# object. And so on each one of our classes here, we'll want to specify an ID that's going to be mapped to the primary key on our SQL table. And then say the patron will probably have a first and last name. And then maybe a simple field for an address, probably like a telephone number, which you could store as a string or as a number. And then in fact, the patron will have some other objects that are associated with it. So if you think of like foreign keys in a database, we'll have some objects like say a library card, which we'll create a little bit later. So we'll actually be able to do things like this as well. So say we have some library card object. And Entity Framework is actually going to be able to map our patron object then to a library card object using a foreign key on, say, like the ID property of this library card object when it's created. So we'll look at that in a little bit. And in fact, we can also call virtual on this, which will allow us to lazy load that library card object. So anytime we pull an instance of patron, we don't necessarily want all of the data that's on library card to be loaded at that time. But we'll cover all of that in a little bit, so I'm just going to comment this line out for now. So you want to make sure, again, that you have installed your Microsoft Entity Framework Core Tools and SQL Server NuGet packages before moving on to this section. So if those aren't installed, then this next part isn't going to work. What we'll do is head over to our appsettings.json file, and we're going to add a new key here called connection strings. So it's going to be a new object here, and we can give it a name. So I'm just going to call this one library connection, and then the string should look something like this. So we'll say server is equal to localDB / Microsoft SQL localDB. And so first of all, this localDB will exist if you have Microsoft localDB installed. And once it's installed, you should be able to confirm it at the command line, and I'll show you how here. So I'm just going to open up command line, and if you just type in SQL localDB info, you should see a series of databases that will be running on your computer. If you don't see MS SQL localDB running here, you should be able to type SQL localDB start and then MS SQL localDB, and that will start an instance of MS SQL localDB on your computer. If for some reason you need to stop and delete the instance, you would call SQL localDB stop MS SQL localDB and delete. But of course you want to be very careful if you are running either of those commands. So back to our connection string here. We now just need to specify a database name. So this can be whatever you like, but whatever you type in here is what Entity Framework will create when we do our first migration here. So let's just call it like library dev, for instance. And then I'm just going to include two more parts in our connection string here. The first is called trusted connection. True, that's just going to allow us to use our Windows authentication to connect to that database. And the second part is multiple active result sets is equal to true. Okay, so we'll just save that. And before I forget, let's go back to our library context, and we want to make sure that we include the models that we created here. So I'm going to control period here and then make sure that we're using this library data.models namespace so that we have access to this patron object. I'm actually going to control period up here and remove unnecessary usings as well. So I'll save this file. Okay, and now to get Entity Framework talking to our database, we need to actually add this library context to our services collection. So in order to add a DB context, we need to add Entity Framework to our library project. So I'm going to go ahead and right click on library, manage NuGet packages, and we need to find Entity Framework core. So I'm going to select this and we'll install it here. This is going to give us access to that add DB context method. And now that Entity Framework core is installed, we'll also need to install Entity Framework core SQL Server, and I'll accept. So we have these NuGet packages installed in both our data layer as well as the web layer. So let's take a look at our dependencies, and then under NuGet. Okay, so I can see that they have been installed here. So I'm going to go ahead now and we'll go into our startup class, and if we come down to the configure services method, as I said, we'll be revisiting this method as we want to include services for our application to use. We need to call add DB context on our service collection now. So add DB context, and we're going to use the library context that we created earlier as the type. So to do that, I actually need to reference the library data project in the web project I have here. So we're going to right click here, and I'm going to go to add reference, and we'll add a reference to our library data project from our solution. So say OK. This will allow me to control period on library context here and pull in the using library data statement at the top of our file. And here I'm just going to pass a Lambda function that we'll call options dot use SQL Server. And it doesn't look like we're getting IntelliSense on this. So let's go to the top of the file here and manually type in using Microsoft.Entity Framework core. And okay, so that gives us access to the use SQL Server method here. And I'm going to put the Lambda on one line down so we can read it all. And then we need to pass the use SQL Server our connection string, and we can get that again through this configuration object that we had built, and we'll call get connection string there. And we just need to specify the name of the connection string that we just added to our appsettings.json, which if you recall was just library connection. So we're going to go ahead and throw that here, and we're missing a single parens. Okay, so you can see I feel like that's structured really nicely, just having this configuration object that gets built here, and then being able to call a single method get connection string, passing that the key from our JSON object, and this is going to provide Entity Framework with the context that we are creating for our library application. So now let's run our first database migration and create our first database. So database migration is essentially just a way of moving a database schema from one state to another. And so anytime we make changes to our schema, which would be, say, like adding a table or dropping a table or altering some columns, and so migrations make that possible. So let's take a look at what happens when we create our first migration. So if you head down to the Package Manager console here and set your default project to library data, first command we'll run is add-migration, and we'll say initial migration, and we just need to put that in quotes. So I'll hit return, and the output we get is simply a remark that if we'd like to undo this action, use remove migration. But more importantly, we see a new folder that was created in our library data project called migrations, and it contains this initial migration.cs file. So this is just a C# file that is going to build a migration for us for our SQL database. So you can see in this case it's actually going to create our patrons table for us and create columns corresponding to all the properties that are on our patrons domain object. Okay, so if we want to commit this to the database, if you will, we just need to say update-database. And the first time that you run this, since we don't have a database created, it's going to take just a few extra seconds. But what Entity Framework is doing now is it's going out to using our connection string, going out to an instance of LocalDB and saying, I don't have a database called library dev here. I'm going to go ahead and create one, and then I'm going to create this table patrons because it doesn't exist either. Okay, and so you see that when it's complete, you just get done here on the console. Now if we go to the SQL Server Object Explorer in Visual Studio, if you don't see this, you can click View SQL Server Object Explorer here. And if we look under localDB/MSSQL localDB, and then under databases, in my case I have two databases here, one for the demo that we looked at earlier, but in our library_dev database, and then in the tables folder, you can see that we have a patrons table. And the patrons table contains columns for all of the properties that were on our domain object. And so it looks like this migration was successful. So if you've gotten this far already, I would say congratulations, because you now basically have a database using Code First hooked up to your application. And so we can now begin to think about how we're going to construct the data that will represent the various objects that we'll need to use in our integrated library system. One thing I would highly suggest doing is, if you don't have Microsoft SQL Server Management Studio installed, I would go ahead and install that, and if you open it up, it'll look like this. It will ask you when you first open it to connect to a particular server name. We'll be able to use Windows authentication. You'll just need to type in parens localDB and then \MSSQL localDB, and then you'll be able to click connect. And if you don't see your database in the list of databases here, just click this refresh button and then re-expand the databases folder, and you should see it here now. So I see library dev. Now if we right click on this and select new query, now we can actually run raw SQL against the database that we created. So for instance, although we don't have any data in it now, I can select star from patrons. And if I run this, I can see an empty table here. And again, now you can see the columns that map to our C# object that we created earlier. Okay, so fantastic so far. Now I'd like to take a short step back and let's just think for a minute about the objects that will need to be represented in an integrated library system. So if we think about a library, it's basically a place where people go to check out media, be it books or video or magazines. And as a library, what I might want to do is manage the patrons that come to my library to check out those assets and the assets themselves, so I can see, where they're going, maybe how frequently they're getting checked out, whether or not they've been lost, whether or not they are being returned late and I need to charge a particular patron some fees. And then I also might want to get some understanding of the various branches that are in my system. So what library buildings contain what assets, what patrons are associated with what library branches. And so you can see we kind of have a system of objects that all kind of interact together here. And on top of that, we need to also develop some type of checking in and checking out system so that we can actually manage the flow of our assets. And so I think it's fairly safe to assume that we should create objects that represent our library assets, our patrons, and our branches. So let's think first about what a library asset object would look like. Well, we would know that it would have some data associated with it, like a title, an author, the year it was published, its cost, and any number of other sort of metadata that are essentially properties on a library asset. But we also need to think about how that asset relates to things like our branch locations. In other words, where is that asset typically stored when it's checked in? And then we also need to think about its state in terms of if it's currently checked out by a patron, if it's lost, at what time did all these things occur. So on one hand, we have some sort of metadata that's directly associated with this object, and on the other, we have some data that will represent this object's relationship or state with other objects in our system. Okay, and so let's think about the patron now. Well, similar to the library asset, the patron will have some metadata, if you will, sort of like the person's name and their address, their telephone number, anything that sort of describes this patron. And then on the other hand, we have data associated with this patron's relationship to other objects in our database. So we can imagine this patron having a library card which has an ID and maybe a home library branch that this patron belongs to, if you will. And then finally, our third big object in the system will be a library branch. And similarly, the properties that might describe that library branch include its name, telephone number, and address. And some of the data that it relates to might be the total cost of assets that it controls or stores, the total number of its patrons. And finally, we should think about a checkout system. So we need to associate an asset with a library card. So we're going to associate assets with library cards as opposed to patrons so that we have one layer of removal, if you will, from our patrons with the items that they're checking out. And that's going to be represented with this library card object. And then we'll want to define a time that an asset was checked out and the time that the asset was due, for instance. And so now let's think about this library card object. So a library card will have a one-to-one relationship with a patron, and in a sense it will represent a sort of layer of abstraction between the assets that a patron checks out and the patron, him or herself. The library card will also be used as the object that contains information about overdue fees and assets that are checked out to the particular patron who has the relationship with the card. Okay, and then finally we'll have some additional functionality to incorporate this idea of holds. And we'll talk about that in more detail as we develop that feature, but that's going to allow patrons to put holds on items while they're checked out by other patrons, such that when the patron who has the item checked out returns it, it will automatically get checked out to the patron with the earliest hold. And then we'll have a concept of checkout history, so we'll keep an audit of every checkout that occurs in the system. And we'll have a concept of asset status. And so that will be a table of static data that just contains all of the different statuses that a library asset could have. So like checked out, checked in, lost, etc. All right, awesome. So now that we have a kind of big picture view of what our objects will be, let's go ahead and create some domain models for them. And then we can run a new database migration so that we have a database schema created for us. So I'm going to go back to the code. I'm going to close the SQL Server Object Explorer for now. And I'm also going to minimize our migrations folder and just rearrange our layout a little bit here to make it easier to see. And what I'd like to do is in our models directory, I'm just going to create classes for all of the different objects that we just talked about. So I'm going to click Add New Class. And for brevity, I'm going to create a class for each of the objects here, and then we'll look at the properties on each of them in a moment. And after all the classes are created, we'll look at them individually. Okay, so I've gone ahead and created all of our entity models here in separate classes that we'll need to use for our application. You'll notice that I can supply this required attribute on any of the attributes that I want to specify as non-null in our SQL database. So notice that I have a class book, which is inheriting from an abstract base class library asset, which has a model in our models folder. And the reason I'm doing this is because you can imagine our library will control a number of different types of things which still have many of the same properties that are relevant to us. So anything that a library will provide as an asset will have a title, a year, the status, which we'll take a look at in a minute, the cost, an image that we can use for presentation in our views, maybe a number of copies, and it will be associated with a library branch. So you'll notice that I have this public virtual library branch property on our library asset class. And so this is going to create a sort of foreign key relationship between anything that is a library asset and a particular library branch. And so when we look at the SQL table after we do our migration, we'll see a library branch ID on the library asset table. Now you may be wondering also how this inheritance is going to work. So we can actually set it up to work a number of different ways. By default, I think Entity Framework Core is going to implement what's called a table per hierarchy strategy, which just means that it's going to create a single table called library asset. And so any concrete class that inherits from library asset will be represented using a column called discriminator on the library asset table. Now to be quite honest with you, that's not necessarily my favorite way to represent data. I don't think it's necessarily bad, but in any framework we can't actually directly select on that discriminator column. It can make it a little bit tricky to think about how to use these concrete classes that inherit from the abstract type, but it is nice on the other hand that all the assets the library controls will be contained in a single table and not spread out across any arbitrary number of other tables like book and video or periodical or whatever other types that you might include in your system. So we're going to work with it and it's going to work out just fine. Next, I've got a branch hours class, and this is actually going to be used to store the hours that our various branches are open. And so on like say a branch details page, we'll be able to control what is shown per branch by something we store in the database, which is a lot nicer than updating like some static HTML. And so of course we are going to need an ID column, and then we're going to need the library branch that each set of hours are associated with. And then we'll have a column for day of week and an open and close time. And so each branch will have up to 7 rows representing each day of the week, and then an open and close time for each of those days. Next, we'll look at the checkout table. And each of our checkout objects, as mentioned when we were thinking about the sort of model structure of our application, will have a library asset, so in other words, say like a book, and a library card, which again has a one-to-one relationship with a patron. And then we'll have a datetime object represent both the since and until dates, which will let us know when an item was checked out and when it was due. Then we'll have a simple checkout history table, which will be a sort of audit table that again just shows when an item was checked out and when it was checked in. We can make the datetime column explicitly nullable here with a question mark. Then we'll have a hold table, and the hold is going to represent the library asset for which a hold has been requested, a library card, which will represent the library card that has requested the hold, and then a date that the hold was placed. And this will allow us to set up a sort of queue structure such that for any library asset, we have a series of library cards that we know requested the hold at a certain date. And then so if we order that by the date time, we have this queue where we can see who came first and thus who we owe the library asset to when it's checked in. Okay, and then finally down to the library asset class, which is sort of one of the core classes of our application. And you'll see that I have defined it as an abstract class, which means that we will need it to be inherited by these concrete child classes like book and video, which we'll see in a minute here. But again, it's going to contain all the properties that any asset controlled by the library would have. And then we have a library branch. And you'll notice I have some other attributes here on these properties. In this case, I can define a maximum string length and some error message. I'm going to take the error message out, but I put it here just to show you how you can pass an error message to this string length attribute. Okay, so we've got an address, telephone number, description, an open date, in other words, say when the branch was founded, and then I have a collection of patrons and a collection of assets that belong to that library. And then we can store an image URL, which will contain an image that we can put on the branch detail page. And we've got the library card asset, which again is another simple class which contains the overdue fees, a created date, and a collection of checkouts that are associated with that card. We have the patron class, which has all of the patrons metadata. And what I'll do now is uncomment our virtual library card property and create a library branch property on it too. We'll call that home library branch. And if you'd want to put attributes to specify like a max length on any of these other properties, you may want to implement that as well. Then we've got our status table, which again is just some static data that will represent the name and the description of the various states that our assets can have. And then finally I've got this small video class, which is just another type of asset. So in our library asset discriminator column, we'll have books and videos. If you're creating this app for yourself, you might also consider adding concrete classes for, say, like magazines or newspapers, or again, any other type of asset that your library branch might want to offer. Okay, now that we've added all of our models, let's go back into our context, and we need to add DB sets for each of these tables. And now let's go ahead and run our next migration. So we'll say add-migration, and we'll call it add initial entity models. And you can see that our migration gets created. This time it's going to be quite large compared to the initial migration that we ran. And we'll just go ahead and type in update-database. Okay, and it says done. So this means that we have actually successfully created a database schema to represent all of the data that we'll need to control in our system. And that's a really huge first step towards developing our application. So congratulations again if you have made it this far. And now what we'll cover in the next video is how we'll write some services that will get used by our controllers in our web application to query and add and update and work with all the data that we'll store in our database. I'll also provide some scripts to populate the database with a bunch of sample data so that it's a little bit more interesting to work with as we develop. And from there, we'll actually implement our view models and implement the model view controller design pattern in our web app. So this video was all about data and architecture and kind of thinking about how we're going to structure our application, how we're going to structure the data. That doesn't always make for the most exciting code, but it is probably the most important step in starting a new project, is just stepping back and taking it a little bit slow at first and kind of thinking about, okay, how is this all going to fit together and how's it going to work? And it makes all the difference on slightly larger projects to take the time and do that up front. Makes your life a whole lot easier each step of the way thereafter. So thanks for watching this video. I hope you enjoyed it. Stay tuned for the next video when we dive deep into creating services and laying out our model view controller design pattern. If you like this video, I'd really appreciate it if you liked and subscribed, and I'll see you next time.